Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in the last lecture we have determined that which reaction can be oxidation and which is reduction based on oxidation number theory. So now we are going to find out that what would be the oxidant and what would be the reductant in a redox reaction. So let us find it out. So as mentioned in your screen, there is a question which is a redox reaction itself. And in this redox reaction, you have to determine that which molecule is behaving as oxidizing agent and which molecule is behaving like reducing agent. So before that, we have to determine that which molecule is showing reduction process and which molecule is showing oxidation process. So let us find it out. How can we determine this redox reactions, reduction and oxidation? Let us see. So this is the molecule that they have been given in the reactant side, that is Cu plus IO3 minus, that should give you Cu2 plus I2. So first of all, we have to determine the oxidation number of each reactant as well as for the product also. So therefore, the oxidation number of Cu in Cu plus is 1 plus, because by observing this charge present on the copper, we could determine that the oxidation number of the copper will be plus 1. And since it is not a molecule, so therefore we don't need to calculate by doing X is equals to that and all. So therefore it has been clearly mentioned that the oxidation number of copper 2 plus is nothing but 1 plus. But for this IO3 minus, we have to calculate the oxidation number of I, that is iodine atom. The reason behind that is, as you can see, the copper which is present here is same the copper which is present there, but which has a different oxidation number. But in case of IO3 minus, as you can see, which is present in the reactant side, has the product as I2, which means we have to calculate the oxidation number of I in this case to determine whether the reaction is oxidation or reduction. So therefore, I could come directly to this thing, that is the oxidation number of I in IO3 minus will be I could calculate it in this way: 1 into iodine atom plus 3 into oxygen atom, which would give an overall charge of the molecule, that is IO3, as -1. Since I don't know the value or I don't know the oxidation number of iodine, so I have taken it as X, plus 3 into the oxidation number of oxygen is always -2. So therefore I could get the answer as X is equals to 5. So this is the oxidation number of iodine. Therefore, the oxidation number of iodine in this case, that is in IO3 minus, is 5 plus. So this is how we have calculated the oxidation number of the reactant molecules. But now we are going to determine the oxidation number of the atom which are present in the product. So in this case, the copper 2 plus is being mentioned. So therefore, the oxidation number of copper in Cu2 plus is nothing but 2 plus. It is been clearly mentioned because it is present in an atomic form and not a molecular form. So we don't have to do the numerical to get the value of the oxidation number. So moving towards the next one, that is we have to calculate the oxidation number of I2. So the oxidation number of I2 is nothing but 0. And we know that how to calculate the oxidation number for a molecule which consists of same number of atoms, or which consists of similar atoms, I would say, not same. which would consist of similar atoms. So therefore the oxidation number of I in I2 is nothing but 0. So let us write the equation in the form of the oxidation number. How can we write? The equation was given as Cu plus IO3 minus, that is giving us Cu2 plus I2. So in this case, the oxidation number of Cu plus is nothing but +1 or 1 plus, while the oxidation number of iodine in IO3 minus was found to be 5 plus, while for this Cu2 plus is nothing but 2 plus, and for iodine we have calculated or we have determined it as 0. So we have to compare the reactant and the product. When I compare the reactant copper with the product copper, I could see that this +1 oxidation number is being raised to 2 plus. This is only possible if electron is being lost. So therefore this process is nothing but loss of electron, and as we know the loss of electron is nothing but oxidation. So therefore Cu plus is showing oxidation process. Now let us see that whether this IO3 minus is showing reduction or not. It will show reduction because it's a redox reaction, but still we'll confirm it. So in this process, as we can see, the iodine molecule, the iodine atom, which has oxidation number of +5, is now being converted into 0. So this is only possible when an oxidation number is decreasing. This is possible when the electrons are being accepted or electrons are being gained. So gain of electron is nothing but reduction. So in this process, the one who will show oxidation is nothing but the reducing agent, and the one which shows reduction is known as the oxidizing agent. So therefore the oxidation is shown by Cu2 plus. So therefore the reducing agent or the reductant is nothing but Cu plus molecule, which is showing oxidation, while the oxidant is the one which shows reduction process, and in this reaction the IO3 minus is showing reduction process, and hence it is known as oxidant. So this is how we have calculated by using a simple method of oxidation number, and yes, we have calculated which one is oxidant and which one is reductant. So let us see few examples more, and then only you could be expert in how to get which one is reductant and which one is oxidant. Friends, this is another example where I have given you to determine which one is reductant and which one is oxidant. So let us find it out. So this is a reaction which is quite hectic to do because we have to find the oxidation number of the atoms which are present in the molecule. So let us find it, and we will find the oxidation number of what? Let us see that. As you can see, this is the sulfur oxide which is the reactant, and again the sulfur oxide which is present in the product. But in this case the common one will be S2, as you can see, and which is present in less quantity. In this case it is S2, while in this case is S4, while the oxidation number, while the oxidation state of the oxygen we already know, but for sulfur we don't know. So we will find the oxidation number of sulfur, while in this case the chromium is +3 in product side, while we have to calculate the oxidation number of chromium in the reactant one. So we will find the oxidation number of the first reactant molecule, that is S2O3 2-. So therefore the oxidation number of sulfur in S2O3 2 minus will be 2 into sulfur plus 3 into oxy, and overall charge will be minus 2. So therefore 2 into X, because we don't know the oxidation number of S, plus 3 into minus 2, which will give you 2x is equals to minus 2. This minus 6 will go over there, it will become plus 6, and eventually we will get an answer as 4, but it will be for 2x. So therefore for x it will be 2. So this is the oxidation number of sulfur present in S2O3 2 minus. So therefore the oxidation number of sulfur in this case is 2 plus. So now let us calculate for the another one, that is for another reactant. So the next reactant molecule is nothing but Cr2O7 2 minus. So therefore the oxidation number of Cr, that is chromium, in Cr2O7 2 minus will be 2 into Cr, chromium, plus 7 into oxygen, and overall charge is minus 2. So therefore 2 into X plus 7 into minus 2, which will give us equals to minus 2. So therefore 2x is equals to minus 2 plus 14. This will give an answer as 12. Therefore the value of x in this case will be 6. So the chromium in Cr2O7 2 minus is nothing but having a oxidation number of 6 plus in Cr2O7 2 minus. So this is how we have calculated for oxidation number of reactants, but the product is also remaining. So the product one that we have got is S4O6 2 minus. So how can we calculate? So let us see. 4 into sulfur plus 6 times of oxygen will give an overall charge as minus 2, or overall oxidation as 2 minus. So therefore I have considered that the oxidation number of sulfur as x. So therefore 6 into overall charge of oxygen, oxidation number of oxygen is minus 2, or 2 minus as you could say. So therefore 4x is nothing but minus 2 plus 12, which is x is 10 divided by 4, which will give an answer of x is equals to 2.5. So basically the oxidation number of sulfur in S4O6 2 minus is 2.5. So this is what we have got. So let us find out the last product oxidation number. So the last product's oxidation number was, that is Cr3 plus. We don't need to calculate the oxidation number of chromium in Cr3 plus, because it is already mentioned in the form of the charge present on it. So therefore the oxidation number of chromium in Cr3 plus is nothing but 3 plus. So this is how we have calculated the oxidation number of the atoms present in the reactant as well as the product. So let us mention it in an oxidation number format. So the equation which was given to us was S2O3 2 minus plus Cr2O7 2 minus, that have given us S4O6 2 minus plus Cr3 plus. So the oxidation number that we have calculated for sulfur in S2O3 was found to be 2 plus, while that of chromium in Cr2O7 2 minus was found to be. So the oxidation number of Cr in Cr2O72 minus was found to be plus 6, while in that case of S4O62 minus was found to be 2.5, while that of chromium the oxidation number is 3 plus. So in this case, as we can see, the oxidation number of sulfur is being increased to 2.5, from 2 to 2.5. So the oxidation number has been increased. It means the electron has been lost by the sulfur atom. So therefore this process is nothing but loss of electron, which is nothing but oxidation. While in case of chromium, we could see the oxidation number is plus 6 and is been converted into 3 plus, which means electron has been accepted by this chromium atom, and this would have led to a reaction which shows reduction. So by this process we know that the one who shows oxidation is nothing but the reductant. So therefore the oxidation is shown by S2O3 2 minus. Therefore the reductant is S2O3 2 minus, while the one who shows reduction is nothing but the oxidant, and in this case the oxidant is shown by Cr2O7 2 minus. So therefore we have determined that which one is oxidant and which one is reductant. So let me give you another example. So this is how we have calculated calculated the oxidation number of the atoms, and by the help of which we have determined which one is reductant and which one is oxidant. So let me give you one example more. So as mentioned, there are two reactants, and we have recently calculated the oxidation state or oxidation number of sulfur in S4O62 minus. So we will write it directly. So therefore the oxidation number of sulfur in S4O62 minus is, we have calculated as 2.5 plus. We have calculated as 2.5 plus. So now for aluminium, the oxidation number of aluminium is, in this case, because there is no charge present on it, so I could consider it as 0. Now the oxidation number of S in H2S will be 2 into H plus 1 into sulfur, and the overall charge present on it is 0. So therefore I could write it in this way. And for oxidation state of hydrogen, we have oxidation state of hydrogen as 1. So therefore 2 into 1, which means the value of X is, in this case, is minus 2 or 2 minus. Therefore sulfur has a overall oxidation state or oxidation number in H2S as 2 minus. Now at last, the oxidation state of aluminium 3 plus has an oxidation state of aluminium is equals to 3 plus. So this is how we have calculated. Initially we have calculated the oxidation state of sulfur as 2.5 plus. Again for aluminium it was found to be 0. Again for sulfur in H2S is found to be 2 minus, and for aluminium it is found to be 3 plus. So eventually we will write the reaction in the format, that is S4O6 2 minus plus aluminium, that should give us H2S plus aluminium 3 plus. So this has given us the oxidation number of sulfur as 2.5, aluminum as 0, for H2S as -2, and for this aluminium 3 plus as +3. So in this case, what we are going to do is, we'll now check for what happens for these two reactant molecules. If this 2.5 is being converted into -2, which means the oxidation number has been decreased, and this मेरा हाथ ऐसा कर लिया, कंटिन्यू चलेगा ना? So in this thing, the oxidation number of sulfur 2.5 is being decreased to oxidation number of -2. So therefore, the electron would have been accepted in this reaction. So therefore, the oxidation number, since it is going decreasing, so therefore there should be an acceptance or gain of electron would have happened, and gain of electron is nothing but reduction. While in that of aluminium, which is 0 in the reactant side and which is converting into +3 now in product side, will be only possible if it is giving or if it is losing electron. So which makes the aluminium to undergo the reaction of oxidation. So overall, what we have find it out as, the oxidant is the one who shows reduction reaction and the reductant is the one who show oxidant reaction. So therefore, the oxidation is shown by aluminium. So therefore, the reductant will be aluminium. While the reduction is shown by S4O6 2-, that means it is the oxidant. So this is how we have calculated or determined that which one would be the reductant and which one would be the oxidant in a following redox reaction, by taking the 3 examples as you have did it. So thank you friends for watching this video, and please share this video with your friends and don't forget to subscribe Ekeeda channel. Thank you so much.